Okay, good day everyone. Welcome back again to our DevOps class in KodeCamp cohort 4. Today we'll be talking about version control and source code management. And specifically we'll be talking about a product called Git and how um it helps our processes as DevOps engineers and helps us to manage our codes better. All right. Okay, so let's begin. So today we'll just go through what version control is. As a very important pillar of automation in DevOps, what version control is. Then we'll look at what version control and how it relates to source code management. These are two terms that are used interchangeably. And so we'll see what they mean and why they are important. Then we'll look at various types of version control and source code management systems and tools. And after that, we'll specifically look at Git. Then from Git, we'll talk about what Git is. We'll look at various Git platforms that we might be familiar with or that might be new to us. Then we will talk about Git concepts, different concepts in Git. And finally, we'll talk about Git commands. So that's all that we are going to cover today. In a subsequent class, maybe we can go on to look at some other more, intermediate or advanced concepts in Git and Git's workflow in general, and some practical hands-on exercises that we can do with Git. All right. So version control. Version control systems are softwares that help teams, that help engineers to keep track of the changes in data in their files and their data and their codes and the entire digital assets. So if you're working as just one single developer on a project, you see that it might be easier to manage your code. It might be easier to manage the various versions of your source code. When a change is made, when you need to take out a change, delete something, that might be an easy thing to work with if it's just one developer. But in a team of various developers, in a team of distributed workers, like say you're working in a team with 5 developers, you're working in a team with maybe 5 developers in 5 countries now. You see that you have various developers making various changes to the code, and everybody else needs to see those changes, needs to know what has changed, what updates has been made. So managing all those changes, if they are not managed properly, it could lead to data inconsistency in code. Maybe I'll have one version of the code on my own system. I'm seeing one version of the code, but another person is seeing a different version altogether. It's a different set of changes. Maybe an update. I can make an update to fix a problem, and someone else is not seeing that update. And that inconsistency can cause a problem to the workflow of the entire team. So tools have been introduced called version control or source code management tools that help teams and help developers to be able to track and keep a central management system of the different codes, the different changes, the different updates, the different rollbacks made by all the developers across various things. So that's what we know as source code management systems and version control systems. And version control systems are important because they help to manage the code base. They help maintain the code base and enable developers to seamlessly work together. A large team can be able to be on the same page when it comes to their source code and their tools. Some problems that you can encounter when you're working without version control, if you're working in a team that's not using version control, you'll see that there's inconsistency in data. The code I'm seeing might be different from the code that's the next developer is saying. For instance, if I get a task and they say, make this update to the code, and I make that update, I will need to send the new code that I've created with the new updates to the developer that needs that update. Okay, that back and forth can lead to inconsistency. This is when somebody makes a change and another person makes another change, right? And these two changes makes two changes to the same file, for instance. Now, how do you work on the updates to that file? Do you take the change from one person, one developer, or the change for the next developer? That conflict is what we know as change conflict. And it can cause problems in updates and the consistency and integrity of your code base. Next, we talk about the speed and speed of development, which can be slowed down when version control and source code management is not in use. So it's important to use version control and source code management. And we have various types of version control tools. We have the local version control, which is basically just the version controls that you have on your system. So when changes are made, these changes are being recorded on your local system as patches. Uh, and other developers don't get to see what's on that your local system. So it's for only you. And if anything happens to the files on your system, those changes can be lost. So to take care of that problem, a central version control is needed. The central version control is like a single server where files are kept, where the source code files or whatever resource file that needs your version control and management reside on a single server. And various developers can have access to that server to make updates or get updates to the files. However, the same problem of a single point of failure, that is, if something happens to your central version control server, a lot of changes can be lost. A lot of problems can come from data loss and data inconsistency. And so this brought about the distributed version control system, where you have developers having a full version, a full exact replication of the remote repository on their individual systems. So um, you have your remote version control server, and you also have a local version control server. You have a remote repository, and you have your local repository too. So all the changes that are made on the local repository are also available on every developer's local repository on their different systems. And this kind of system is called a distributed version control system. An example of a centralized version control system is Microsoft Team Foundation system, or the Apache source version, that's SVN. And you also have for the distributed VCS, a very popular one that most of us know today, and many developers use, and many source codes are managed on. It's what we have as Git, right? So that brings us to Git. Git, I'm sure if you've been in tech, or if you've worked in tech for some time, you would have heard about Git at least once. A lot of code that we know today, open source code, um, is held on Git. It's one of the most popular version control systems that is in use in our modern time. Git was also created by Linus Torvalds, if we remember him from our Linux lectures. He's also the engineer that created Linux. So he also created Git in 2005 as a version control system to manage code. And coincidentally, you can find the source code of Linux also being managed on Git. So some popular platforms that we used for version control are GitHub, which is one of the most popular. You have GitHub, which uses Git to create a remote repository for source code. You have GitLab, you have Bitbucket, which is mostly used in enterprises. You have AWS KodeCamp, which is a proprietary repository, a proprietary Git repository within the AWS cloud platform. And finally, we have Azure Repo, which is also a Git platform used as part of Azure DevOps tool. Okay, so for some concepts in Git, when you're working with Git, some things that you usually come across, and some terminology and some concepts that you need to know about is the concept of branching, pushing and pulling, forking, merging, creating a pull request, and continuous integration and continuous delivery. When you're working with Git, the concept is that you have a central repository for code changes. If you want to make a change to the code, it's a good practice to create a separate version of the code to make your changes in. And if everything is tested properly on that separate version, you can now include it into the main version of the code so as not to make any changes that can cause an error on your main version. Okay, so that concept is known as branching, creating a separate replica of your main code in order to make changes or make updates to before applying it again to your main branch. So it says a branch is a parallel version of your code within your Git repository that allows for a separate development and experience. So when you create a branch, you're creating an isolated environment with the same replication of your code to make changes to before putting it back into your main code, right? Now, the concept of pushing and pulling from your repository. Say you have your remote repository, right? And you have 5 developers, and one developer makes a change and updates it to the server, to the remote server, right? And another developer needs that update that has been made. For him to get that update, he needs to download the change that has been made into the repository. That process is what we know as pulling. If you need to pull changes, if you need to pull the current state of your remote repository into your local repository, you are pulling. But making updates, which is the process of uploading the changes, uploading the files, uploading the modifications or observations that you've made on your remote repository to from your local repository to the remote repository, so that it can be seen by other people working in that repository. It's what you call pushing. Is there anyone that doesn't know what a repository is? Just drop it in the chat so that I'll know how to explain that. If you don't know what a repository is, this repository I'm saying, you don't know what that is, just let me know in the chat. Now, to cloning and forking. When you're working with a repository, cloning is the act of creating an exact replica of the entire repository, which includes the various commits that are on that repository, various branches on that repository, the various previous versions of that repository into your local machine. Downloading it as it were, all the changes, all the entire history, all the branches and all the various commits that have been made. into your local repository is what we call cloning. Creating an exact mirror is called cloning into your local repository. But if you just want to get a copy of a repository still on your remote server, you fork the repository by creating a replica, but not in your local machine, still on your Git platform, but an exact replica. Okay. Then to the concept of merging, we talked about a branch, creating a branch. So before you create a branch, the branch that you're working on is what you call your main branch or your master branch. If you check out or break out of that branch to make a change, either in a feature branch or a something for a fix, a hot fix kind of branch, or a development branch, as the case may be, after you've made your changes to this branch, this isolated version of the code, after you make the changes and you want to put that change, you want to apply that change to the main working branch that everybody is working on, you do a merge, which is merging, just as the name is saying, merging, applying the changes that have been made on the main branch. And in a situation where changes are made by multiple people and they are able to be merged to the code, it still creates a problem where anybody can make any change and merge that into the production branch, the live main branch. So we need a process by which people need to be able to approve the changes that are made before they go into the main branch, right? That's what we call a pull request. When when you're trying to merge, a pull request is like an application you make that needs to be approved by other developers to say, yes, this change has been tested. This change is not going to break anything. We have tested this change, and this change can now go into the main branch. This change that you've made in your separate isolated environments can now be applied to the main remote general environment. That pull request can either be approved or rejected. So you create a pull request asking if you can, making a request, an application, if you can merge into the main branch or into any branch at all. And when that pull request is approved, you can now merge into the branch. Finally, the process of continuous integration and continuous development speaks of the process of constantly building, testing, deploying code changes, creating some form of automated process of building out and testing changes that are going to be made for deployment. Okay, I hope that is clear. If anything is not clear, just let me know in the comment section and I'll come back to it. Finally, some Git commands. This is closely related to the things that we've just talked about. We have commands that are commonly used in Git, just like we have commands that are used on your terminal. When you download Git on your terminal, you have the CLI commands that's used to interact with your Git program, your Git process running. You have Git branch, which can be used to interact with the various branches on the repository that you're working with, either the local branches or the remote branches. So Git branch, you can use Git branch to display the branches you have. Git checkouts is used to go into a separate branch. You can use Git checkout to move into another branch. Say you're currently working on your main branch. Git checkout helps you to move from that branch and go into another branch. You can also use Git checkout to create a new branch of your code repository. Git status checks whether there are any changes to files that are in your Git repository. If you make any updates, if something has been modified, if a file has been modified, you use git status to check which file has been modified. You use git status to check which files have been deleted, if any new files have been created, whatever updates has been made to the repository locally. Use git status to check the status of your branch, if it's up to date with the remote repository, if there are any changes that have been made. Now, git add is used for staging. When you stage, the concept of staging is putting up a particular change to be monitored by Git. So you can have various changes that are made, and Git sees these changes. But in order to be able to push these changes to push these changes from your remote repository, from your local repository to the remote repository, you need to stage them. You need to set them up to be able to be pushed so that they can be separated from other changes that you don't want to push to your remote repository, right? So staging it's like a process of grouping a particular set of changes to be pushed into your remote repository. Pushing is the process of moving a change from the local repository to the remote repository, from your local system to the remote server. The command used to do that is git push. So git push, then you specify where you're pushing to, where you're pushing from and where you're pushing to. So I can do git push from my local repository to my remote repository, right? The next is git pull, which is used to download, to include changes from the remote repository into your local repository, so that whatever change has been made by maybe your other developers, you can pull them into your remote repository so that you can also work with those new updates and new changes. Git logs can be used to see all the activities that have been done on Git within your local repository. And even by other developers, you can also see things like commits, things like updates that have been made on Git. Git init is used to initialize a repository on your local machine. So you can have various directories, various folders on your machine. But in order for Git to be able to monitor a particular to see a particular directory as a repository, and to manage the files in that folder, in that directory as source code, you need to initialize that repository with git init command, right? The git config command is used to work with the Git runtime and make configurations to it. You can decide to set up your set up security on your Git, and decide to set up your emails, your name, the name that Git is configured with, and various other settings that you need to work with for your Git tool. You set that up using Git init. Now, our merging is done with Git merge. Git remote is used to either set up, change, or update the remote repository, because all these commands are used on your local system, right? So if you want to set up a remote repository or work with a remote repository that you can push from your local repository into, you use Git remote. Git reset is used to delete changes that have been made within the Git repository, while Git reverse is used to roll back to a previous change, a particular change. If you want to roll back to a particular change, use Git revert. If you want to delete changes that have been made, use Git reset. And Git fetch is used to, it's similar to pull. It downloads a change that has been made to the remote, that has been made on your remote repository, but it doesn't apply that change on your local repository. Git fetch just pulls down that change, right? So these are some of the basic commands that you use when working with Git. Git branch, Git checkouts, Git status, Git add, Git push, Git pull, Git commits. We didn't talk about Git commits. Okay, Git commits, Git logs, Git inits, and so many more. These are just some of the basic commands that you use while working with Git. Okay. So that's the basic discussion on Git that we have. If there are any questions, just put up your hand before we get into any practicals. I'll give you a few minutes for questions. Okay. So I think the first thing we can do is to go into sketching some of these things that we have talked about, just to describe it better, right? Okay. So let's take a question. Let's take one question from Thank God.
Okay, good evening, class. So, my question is, we mentioned three types of Git, I think. So I want to know which one exactly. Sorry, three types of version control systems. So I want to know which one exactly Git belongs to.
Okay, thank you. So that's a fantastic question. When you speak of Git, first of all, you notice that I was speaking a lot about a remote repository and a local repository, right? So if you're working with something like, let's look at them. Let's quickly look at them. If you're working with a local version control system, the version control for your whatever resource you're working with, your source code, is maintained in the local computer. There is no remote server. There's no remote repository. There's no remote version for 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 that um for those resources, right? If you're working with access and get changes and upload changes to, they don't maintain a local version of that server. They don't maintain a local version of that repository, right? But with the distributed version control system, there is both the remote repository and the local repository, which is a direct mirror, an exact replica of what you have on the repository, sitting in the local computer of everybody, or everybody collaborating on that project. So if I want to collaborate on this project, I can just go to that repository and get an exact replica remote repository on my. So with Git, we have both the remote repository, which you can set up with any Git platform of your choice, either Bitbucket or GitHub or GitLab. We have that remote repository, but you also have a local repository that you work with, right? So you have the remotes, you have the local, and that makes Git a distributed version control system. Instead of having just the remote or having just the local, it has both, and that's a distributed version control system. Right. I hope you got all that.
Yeah, that's fine.
All right. Okay. Is there another question? Hello. Oh my goodness. I have been explaining so many things here. I apologize for that. I didn't know I was muted. So I was just explaining some of the various concepts that we have in Git, right? So I was talking about the Git pushing and pulling. In pulling and pushing, you have your remote server that has a particular version of your code sitting on your remote repository. Say you have various developers, your front end, your back end, the data, and DevOps. Pushing is the process of uploading a version from your local repository to what you have on your remote repository. And say that is what is being done here. This update was pushed to change this from version 2, from version 1 to version 2. And all others can now pull that change that has been made. With branching, you have your main branch, right? And that can now, from your main branch, if you don't want changes made that can corrupt your main branch, you need to create a different branch to make your changes before merging it back into the main branch. Creating that isolated branch, creating that isolated environment, that isolated version of the same changes you have on your main branch for you to make your changes to is what we know as branching. So branching breaks out, checks out from the main branch. Changes can be made there and now can now be applied later to your main master branch, which can always be reverted or rolled back to, as the case may be. Moving on to pull requests. Let's talk about pull requests now. Um, in a case where you have your main branch, this is your main branch, which is the version of the code that is live, maybe that users are already seeing and interacting with, which is maybe currently running on production. You don't want any changes that can corrupt or cause damage or errors to this main branch. So when a feature branch or a different branch is created, for those changes to be applied to the main branch, there has to be some form of authorization and approval from other stakeholders, other developers, right? That's requests for merging into a particular branch is called a pull request. And your pull request will need approvals. And after the approvals, the merge can now be completed into the branch. So that's the basic concept of a pull request. What other concept did we talk about? Who can remind us? Talked about pushing and pulling, talked about branching, talked about pull requests. Cloning. Okay, I did it.
We also talked about reverting.
Okay, we have reverts here, right? That's when a change has been made and you want to move back to a previous version, right? You revert, moving back to a previous version.
fetch.
So you have cloning. So this is your remote repository. Right? Creating an exact replica of what you have on your remote repository into your local repository. It's your process of cloning. Okay. So this can be cloned. From the remote repository. So as many developers as possible, as many and clone this remote repository into their local, right? As far as they have access to this remote repository, they can always clone it. But in a situation where this is developer one, here we dev two, and dev three. The remote repository was created, and all these developers have access to this remote repository, so they can clone it to their local system. Assuming you don't want to clone it to your local system directly, you just want a replica of this on your own personal remote repository, right? Say I am this repository, this remote repository belongs to dev one, and dev three wants this on his own repository, for instance, dev four. He wants it on his own repository, local remote repository. You can still create a replica of this on your remote repository without pulling the changes, cloning it onto your local system. That is known as forking. And with forking, you don't need access to this repository. So here we have cloning and forking. Okay. So I hope I've been able to explain the basic Git concepts that we work with when working with version control. Okay.
Sir.
So any questions now? Any questions? Okay, go ahead.
So I was going to ask if you could just do a version of fetch, just as you explained pull here. You can just do that of fetch as well.
I didn't quite get you.
Like while explaining earlier, you talked about the slight difference, almost the similarity between fetch and pull, and the little difference between them. So I was hoping you were going to explain, just as you explained pull here, you're going to explain fetch as well.
Okay. So pulling is very similar to fetching. The difference is that with pulling, you're applying the changes that have been made. Let's say we have another, okay, this is the data analyst guy. He hasn't pulled the change yet. So with pulling, you are applying the changes that have been made to version 2 onto your local repository. Or if you're fetching, for instance, you are just keeping that version within your local repository too. You don't necessarily apply it to what you have, okay? But you have that version available for you. So you can still be working with your version 1 or having version 2, and you can apply it at any time. So fetching doesn't automatically apply the changes. It just pulls down, it just gets the changes that have been made. I don't know if that's clear. Okay. So in our next class, we're going to work on the practical implementations of these various commands, right? But for the practical that we'll do in this class, we're going to try to create a GitHub account for ourselves. Before that, please put up your hand. Who can tell me the difference between Git and GitHub? Put up your hand, then I'll call somebody. The difference between Git and GitHub. Our exercise for today, what we're going to work on practically, is to create a GitHub repository for ourselves. So who can tell me the difference between Git and GitHub? Okay, the first hand that came up is Michael Woodby. Go ahead, Michael.
Michael Ngube. Okay. So Git is like the version control software. GitHub is like a cloud platform where all our repositories are being stored, so that we can have them could have remote access to them online. But what organizes the repository is the Git software itself, like the version control software. That's Git.
Yeah, that's a terrific answer. Thank you, Michael. Arinze, go ahead. What's your answer?
Okay, good evening, everybody. Git is the software that we can install on our system so that we can use it to push codes that we have on our system to the GitHub, which is the online platform where people create accounts to store their codes and make changes to it, and also get access to it whenever there is a need. And GitHub also helps people to work together. Like if I have a GitHub account and another person is working on the same project with me, I can share the person my GitHub account. The person will now go and pull the code and retrieve it and pull it to his own Git, using his own Git, then work with it and also push it back so that we can collaborate.
Yeah, thank you. That's a very correct answer as well. Thank you, Arinze.
Thank you, sir.
Okay, John. You have a different answer.
Okay, good evening, sir. Good evening, everybody. Yeah, so from my understanding, Git is a version control system. It's essentially the software that enables us to version our repos and our software, our scripts and the likes. Yeah, so it's a CLI tool that is essentially installed on our system. So GitHub is like the graphical user interface that enables us to visualize, the versions we're doing on the Git, and also help us to host those codes in a remote repository. So it enables
Yeah.
us to see clearly what we're doing in the Git.
Okay. Yeah, that's a great answer, sir. Thank you, everybody. So we are going to go into the practicals now to create our Git repository. So where can we begin? Okay. So you can just go to github.com. Trusted by world's leading organizations. So are we all here? How many of us don't have a GitHub account? You don't have one. So we all have GitHub. Hello? Is there anybody that doesn't have GitHub? I need at least one hand up. Somebody that's can follow along. Anybody? How many of us have GitHub accounts? Can we? Okay. Okay, thank you. Put down your hand. Thank you. So when you come to GitHub, you can simply click on sign up right here. When you come to github.com, you sign up, and with that, you can put in your email address. Then click continue. Okay, go ahead, Etim.
I think your screen is showing Google. I thought you were explaining the process of GitHub and you were on GitHub page. Okay, it's up now.
Okay. Thank you for that. So you go into github.com, then sign up. When you come to sign up, you put in your email address. When you put in your email address, you can now continue and create your account. I have already created my account, so I can sign in easily and go to my accounts. And with Git already downloaded on my system, my Git CLI. I hope you have Git CLI downloaded as well. Okay, so with Git CLI, I can now interact with my remote repository. from my local. So that's bring us to the end of this interactive session on Gates. In our next class, we're going to look practically into GitHub, creating repositories, and working with the various commands that we have learned. All right. Thank you, everybody, for joining. And Anthony, you have a final question on GitHub.
Yes, good evening. Okay, you just said Git CLI. Is it the same? Yeah, is it the same thing like Git Bash?
CLI, yes, that's just the command line. So,
Just Git. Okay.
command line interface. Sorry. Yeah, so when I say CLI, I just mean the command tool, your terminal tool. Yeah.
All right.
All right. Thank you, Anthony. Thank you so much, everybody, for joining. I hope to see you in the practical lecture. Please, let's always be open to doing our research as well. All right. Thank
Hello,
you
sir.
so much once again.
Sir,
Goodbye.
sir, good evening. Sir, have we ended today?